Hello, good afternoon. Thank you for joining us for another ADLINK podcast. My name is Mondo Mikhail. I am your moderator. Today we have a discussion on Intel at the Edge, how integrated compute is powering the future of medical imaging and diagnostics. Today I have a very distinguished guest, Beenish Zia. She's an electrical engineer and chief architect for medical imaging and lab tools at Intel Corporation. Beenish is a visionary with a passion for transforming healthcare through innovation, strategic foresight, deep technical acumen. She's a recognized architect, breakthrough solutions in the intersection of AI, high performance computing, and life sciences. Beenish, thank you for joining us today.
Nice to be here. I'm doing well. Thank you.
All right, we got a really exciting topic today. Let's start out. Help us understand what Intel MedTech is and how that's driving healthcare and life sciences and its vision for the future.
Sounds good. So before I go to Intel's MedTech part, I would like to start with Intel's vision. As most of you know, Intel put the silicon in Silicon Valley, and its mission is to create world-changing technology that improves the life of every person on the planet. And Intel has been doing this for more than 50 years. At Intel, its people have had a profound influence on the world, driving business and society forward by creating these radical innovations that are happening in health and life sciences, but other industries too. And today, with the business unit like healthcare and life sciences that focuses on the medtech medical technology part, Intel is enabling its customers to capitalize more fully on the power of digital technology. And our vision is, how do we bring world-class solutions in the healthcare and life science space, which will ultimately impact the patient journey. And this patient journey can start from the time your blood work is done to so imaging is done, or how your electronic health record is getting processed. The whole spectrum of improving and bringing world-class solutions to improve the patient journey, that is our vision. And I want to be clear that this vision is not static. It's an ongoing process of continuous improvement and evolution. And that's what helps us lead and innovate with partners like ADLINK and our customers with the goal to improve life through technology.
That is a really compelling vision. A big thing we're seeing today, everybody's talking about in healthcare, is the aging population and the increase in demands on the aging, increased demands on the healthcare system itself. As technologies become more and more advanced, more and more powerful, they're producing huge amounts of data. How is that changing the way Intel produces its silicon to meet these demands, to meet these processing needs, both more at the core and also more at the edge, where power and heat are a big factor?
Yep, no, completely agree. So as you mentioned, the aging population is increasing, and that is one of the mega trends we are seeing in the healthcare and life science industry. Is the aging population is increasing. Also, the chronic disease management is increasing, and all of that is leading to a high increase in demand of imaging, diagnostics, and monitoring. And adding on to that, the other trend is there's a global shortage of healthcare workers, which is causing a demand in AI-based solutions and operational cost efficiencies. And then adding on to those pillars, like you mentioned, there is a huge amount of data deluge that's happening in healthcare and life sciences. For example, in the past 10 years ago, if somebody gets a CT scan done, a normal CT scan image would not be as high of a resolution as the latest generation CT scan. So maybe previously it was like 256 by 256 bits of depth of resolution. Now an average CT scan could be 1024 resolution. So the resolution is resulting in highly deep resolution images, which increases the size of the image per scan. And then adding on to it, the number of scans happening per day is increasing. So just for simple imaging modalities, the amount of data generated per year per day is increasing significantly. And adding on to those trends, there's also across all industries, so this applies to health and life sciences also, is that more and more AI is getting integrated. That is also adding its own layer of data diluted, its own layers of data processing, data analyzing. And in health and life sciences, it's estimated that by 2032, the Gen AI, the generative AI market is going to be a 21.7 billion market. So that's also driving what we do. And the last pillar that's really important, which you kind of touched also, is that there's a lot of security, data privacy, data management issues that also involve. So we at Intel are trying to combine all of this and think, how do we build the right silicon, the right solution, the right system architecture in collaboration with our partners that addresses these different trends that we are seeing, so that we can really bring the right solutions to the end consumer, which would be the patients and the professionals in the health and life science industry.
Yeah, one thing I noticed, I was having an encounter at my doctor not too long ago. Yeah, I don't go to my doctor often, but I noticed the medical practitioners doing a lot of compute and imaging right at the edge. I used to see, medical scans and so forth, but they were doing very high resolution images. As these images do get pushed further and further out, the need to drive it with smaller and smaller devices. How has Intel met that challenge with their CPUs and silicons?
Yep, great question. That is a trend we are seeing too, that more and more compute is getting pushed to the edge or on device. And the difference is the way, or maybe the way we defined edge would be the processing gets done next to or close enough distance to the device that generates the data. And this is a trend we are seeing, that since more edge deployment is happening and more AI is getting added to those edge devices, it's top in mind for Intel to build edge devices that are powered by AI. And one thing Intel has done, which also addresses the need of faster performing system at lower cost, lower power envelope, is to have all of the integration done at an SoC, a system of chip level. So our current generation of Intel Core CPUs, which are low power performance CPUs, they not only have the traditional CPUs for vector-based computation, but they also have integrated accelerators like integrated graphics processing unit or GPUs, as well as integrated neural processing units or NPUs, which helps accelerate those AI workloads and helps the developers to get more benefit out of the compute that's at the edge. And then if the edge deployment needs high power system, like sometimes with the MRI machines, you would see an actual rack server sitting next to the machine. So those servers are run by our high-end Xeon server CPUs. And even in those server CPUs, from our 4th generation Xeon, we have embedded AI accelerators called Advanced Matrix Extension or AMX. And what it does is it has lots of matrix multiplication hardware inbuilt engines and also local registers that helps you do those AI calculation faster, store it locally, and process it and then move it to the next block within the system. So that accelerates AI or high performance computing workloads at the edge. So those are some of the things Intel is doing. Of course, there's a lot of other things we are looking into, but definitely AI at the edge with integrated accelerators is top of mind for us.
All right. I mean, the hardware is a fascinating aspect, but a lot of the secret sauce too is in the software. There's a lot of software currently that's used in the industry, going back a ways, that's in a different type of software development architectures. In order for customers to really take advantage of the Intel silicon and all the benefits of the GPUs that are on die, how can they take some of their legacy code and really port it over with minimum risk and minimum time to keep their systems up and running and provide greater capability?
Great question. That is something Intel has more than 10,000 engineers invested in it. And one thing I like to mention before I respond to the question is when people think of Intel, they usually think of hardware. But what they don't realize is Intel has a huge number of software engineers working to enable an open ecosystem and help developers and programmers take more benefit out of the silicon we create. So going back to your question, one thing that Intel has realized by talking to our customers is the developers and programmers want to write the program once and deploy it everywhere. They don't want to worry about what hardware lies underneath. They just want to make the best program that's hardware vendor neutral. With that understanding, Intel is really into open ecosystem. And one thing we have done is we are working with One API, which is an industry specification for hardware vendor neutral programming. And Intel has an implementation of One API. And what it does is it helps you take a CC++ base course or CUDA base course and does an automatic conversion into dual parallel C++, DPC++ based programming language that then helps you write code that will work on Intel or any x86 architecture, as well as work on NVIDIA GPUs. So it gives you the flexibility to write your code and deploy everywhere. So it really helps enable the ecosystem with portability, avoid vendor lock-in, and as well as support an open standard that then allows developers to build cost-optimized performance solutions across multiple platforms.
With all the data being pumped out there, especially in the healthcare space, when you're going into an organization and talking to some of their C-level people, their CIO, their CTOs, I imagine security is one of their top concerns, to protect their data, be compliant to the industry, and really look after their customers to prevent data breaches. What's inherent in the Intel silicon that can really alleviate concerns that give them greater confidence that there'll be less opportunities or less access to data? What's inherent in the silicon to support that?
So Intel, much like how processing is important, security is another really important pillar for us. And we are building products that in healthcare and life science space, you will see cybersecurity as patient data safety as well as privacy. So we have a long list of security capabilities that are in the products that Intel offers that will range from built-in encryption, secure boot, trusted execution environment, and many more. And a few examples that I can give is, for example, we have platform trust and integrity, which includes technology like total memory encryption. So if you are having a virtualized deployment and you can try to make that at hardware level stay encrypted, that's what memory encryption gives you. If you want to do workload and data protection, then we have technologies like software guard extension or on our Intel Xeon products that helps you do applications like federated learning. And then if you look at designing things which need crypto optimization or acceleration, then we have technologies like Intel Quick Assist technology. And those are really focused on making sure how do we design systems that are more secure with built-in security at hardware level that gives the healthcare and life science professionals and the users more ways to make sure the patient data stays safe and private.
It's quite compelling. Everything from the silicon to the porting the software on the silicon, and then from data encryption technology, secure boot. That's really a well-rounded offering that adds a great deal of value in the medical space. Beenish, before we wrap up, what advice would you give today to healthcare leaders planning their compute strategy for the next 3, 5, or 10 years?
Yeah, so I would give 3 advice. The first one would be look for compute platforms that have a balance of performance, cost, and power. So if you're trying to accelerate your solution using AI, rethink if you really need a discrete accelerator, or can you get away by using an integrated accelerator within the same system on chip that gives you the performance you need within the cost envelope that you need and within the power envelope and the form factor. So think about that. Secondly, consider the ecosystem that supports your rapid AI deployment and think about how do you securely acquire, process, manage the data, and store the data. And lastly, consider Intel's roadmap because what we are building is we are helping to build a range of Intel platforms from the lowest core Intel Atom to Intel Core CPUs to Xeon Workstation to Xeon scalable processors to our discrete graphics to give you the flexibility and scalability no matter where you're deploying, especially on the edge. So it will give you to program once, but deploy in a variety of ways your solutions from the lower level to the highest level. So that would be my three advice to folks looking to deploy the solution in healthcare and life science space.
Sounds like wonderful advice to me. Beenish, thank you so much for joining us today. We could have had a much longer discussion here. Really fascinating. We want to thank everyone for joining us for today's podcast. We hope you enjoyed it as much as we did. And again, I'd like to thank my special guest, Beenish Zia. For those interested in taking a deeper dive, we've included a set of resources in the notes section of this podcast covering everything from breast cancer detection, radiology with use cases, white papers, and integrated GPU strategies. Thank you.
Thanks for having me.